So, the format, I did not get any confirmation because Marina hasn't talked to me yet, so I have no idea. But one of the students, I don't remember who, but one of you, I think one of the students asked her, and the one that's pinned in general, that's the one they got from Marina, but I have no idea. I have no information. Is term test really harder? No, I wouldn't say usually, because term test is usually the level of difficulty is usually different based on how well you guys did in the first two quizzes. So if you guys do bad for example, if you guys do extremely well, sorry, got a scam call. If you guys do extremely well in the first two quizzes, then the term test is usually gonna be harder than the quiz. But if you guys are not doing well in the first two quizzes, then usually it's gonna be easier. What count as bad? So for example, if they're expecting you to do extremely well and you guys are not doing well, then they count as bad. So it's like their expectation. That is part of the reason, even though your quiz 2 is not even marked yet. I told Marina, I said you guys didn't do well. Well, why do you think I told her that? It's like I told her so when she prepare for a midterm, she's gonna keep in mind that you guys didn't do well. So level of difficulty compared to regular, it's hard to say. The main reason, I'll tell you why, because for your professors, it's not as easy to judge the level of difficulty, because they've been doing this for many years, and from their perspective, everything is really easy. Okay, it's like I ask you to make a test for kindergarten math. Okay, so from your perspective, everything is easy. So for them, it's really hard to decide what's easy and what's hard. You know what I mean? So it's like right now you go back to kindergarten, you make a test for them, you'll think everything is easy. You'll think whatever you give to them is like so chill that they all should get perfect. That's exactly how your professors are like, because everything is really trivial for them, so it's hard for them to judge the level of difficulty. So it's hard. Okay, they might try to make it easy, but well, the easy is probably what they think is easy. But you know what professors think is easy and what you guys think is easy might be really different. That's hard to say. What year did Marina? All the years except last year, I think. Last year in 2020 or something like that. Last year was not her. The year before was her, and 1 year was Mike. 2019 was Mike. But other years, I think. Oh, and if you go back, really back, like 2017-ish, it was Shy. Shy was coordinating. So from 2018 till now, only 2 years she was not coordinating. 1 year had Mike Pulu was coordinator. The other year, which is last year, had Jimbo and Nadia. Yeah, I'll post the recording. This is the first time I actually remember to record. So of course I'll post it. Any other question before we start? It's hard for me to talk. Oh yeah. I have no idea. I can't even show you. I can't even show you. What mark? Just give me a moment. You're going slow. That's all I can say. So if you look at homework 2, for example, it's not done yet. You see, question 2 is 48% down. Question 3 is 3% down. So they're grading, but it's going slow. And if you look at quiz 2, version A, 1B is complete. 1A is 13% down. 1C is 7% down. Question 2 hasn't started. And version B, I think only 1B is complete. 1B, yeah, 1B is complete. And everything else is barely started. Okay, so no idea. Hard to say, no idea. Yeah, we we have a lot of students. There's and as you guys know that a lot of TAs, including me, got sick. You cannot force someone who's sick to do work, right? So I have no idea. Back to this. Wait, I'm supposed to share my screen, but why is it not sharing? Oh, okay. Oh, I entered the wrong Zoom chat. Makes sense. Okay. Let me see. Let me see. Can we go over proving the union of intervals that are polynomial? What exactly do you mean? Union of intervals that are polynomials? Is that a thing? I wanna ask the same thing. I mean, intervals are sets, they're not functions, and how do you make them polynomials? I'm not sure what know what you're talking about. If you have a specific question, you can show me, but I don't think I know what you're talking about. I think someone DM me. Okay. 2017 meter. Okay, so let me have a look. 2017 meter. She posted it? Oh, I see. Meter. Oh. Okay. You said it in a really weird way, but they're talking about this. Express the set as union of interval. So x is in real number such that x squared plus x minus 6 is greater than or equal to 0, and x minus 4 is less than 0. So we need to express this. That's not polynomial. Okay, that's inequality. Express it as a union of intervals. It's okay, not a big deal. Okay, so first of all, you need to figure out what S is, right? So you should simplify this and this to figure out what it is. So if I want to simplify, let's say the first inequality, what do I have? If I simplify this, anyone? If I simplify this, what do I have? You would treat it as equality first, right? Remember from before, we said we would treat it as equality first. So you think about this as x squared plus x minus 6 equals to 0. You can do this, factor out, 2, 3, so will be like this. So you have x plus 2 times x minus 3. Okay, and then we want it to be greater than or equal to 0. Right, so you can draw an interval -2, 3, like this. Did I make a mistake? Oh, plus. Sorry, my bad. You guys are right. See, I told you my brain is not working today. Let's change it to 3. Let's change it to 2. This is -3. This is 2. Okay. Yes, you are correct. All right. So now you can determine which interval will be greater than or equal to 0. So for example, -4. That's minus, that's plus. 0, for example, minus, plus, so it's minus. 3, 3 will be plus, so plus. Okay, so using this, you know that, well, I need x to be, it's greater than or equal to, so less than or equal to 3, -3, or x is bigger than or equal to 2. Okay, so from here, this is what we have. Okay, from this, combine with this. This is saying x has to be less than 4, right? So you can draw it on this real number line. So we need this, we want this part, or this part. And is less than 4, so less than 4. So let's say 3, 4. Okay, remove 4, like this, and this. Okay, so combine everything together. You would have this part and this part. Agree? Do you guys agree with me? Because you need both conditions to be true. Yeah? Okay, so the first part from here, it's basically, we have intervals, right? Union of intervals. So that's -infinity to -3. We want to include 3, so we use this bracket. And the union from 2, we want to include 2. Okay, and we don't want to include 4 because it has to be less than 4, cannot be equal. So this is the final answer. Can you explain the number line? Sure, of course. Hey, let me zoom in. Okay, so let me change color maybe. So let me remove this because this we got it from different places. Okay, so my goal here is I know this, right? I know this. Now I know that when x is -3 and when x is 2, this expression would equal to 0. Do you agree? Okay, so the key point is -3 and 2. We know that because at those 2 points they equal to 0, if you want to be positive or negative, it has to cross those 2 lines, right? Like this or like this, you need to cross those 2 lines. So checking the numbers before this, in between, and after will be enough. Okay, so basically what I did is check a number, let's say -4 here. -4 minus 2 is negative, so I put a negative sign here. -4 plus 3 is also negative, so I put another negative sign here. Because you have a negative number multiplied by another negative number, you'll get a positive number. Does that make sense? It's not a proof here, like this whole thing, it's not a proof. You can use it in calculus, but you should not use it as a proof in 102, okay? It can give you the answer, but it's not a proof. So, yeah. If you wanna do it algebraically, for example, you need to discuss cases. So you'll say, oh, for a product to be positive, they must have the same sign. So it's either this is greater than or equal to 0, this also greater than or equal to 0, or they're both less than or equal to 0, and then discuss cases. But in this case, we're not asking for a proof, it's a fill in the blank question, right? So whatever is fast, you do it. Make sense? And the other part is just I added this restriction out. Alright, so let's start the tutorial stuff. Okay, we've been talking about other things. This is important, that's why I'm having an extra tutorial. It's quite important to do this. It's like one of the most common mistake in this chapter. Well, I'll tell you in a moment, but before that, let's talk about logical equivalent. We say two statements are logically equivalent, okay, logical equivalent, if they have the same truth value. So, how do you show they are logically equivalent? You construct truth table. Okay, you construct truth table. In the first part of tutorial 4, I've been telling you, well, you don't need truth table for those type of questions. But if it asks you to show two things are logically equivalent, you construct truth table. It's the only way to do it in this course, because we don't really teach you the identities. Okay, so this is basically the only way to do it in this course. Construct truth tables, which requires you to be extremely familiar with the truth table, you know, the connectives, you know, what we've been talking about. Okay, that is why I've been telling you know this by heart, because, well, it's all about truth table now. So that being said, this should be 3 marks. Do I need to draw helper columns when doing? You don't have to, but we recommend it. Why? Because it's very possible you make a mistake in between, right? If you don't have the intermediate step, then your TA can only look at your final answer. If it's wrong, they deduct all the mark. However, if you have the intermediate step, that shows the marker, you understand stuff. You just made a tiny mistake in between, for example, then they might give you partial marks. Okay, so this is the same for a lot of things. Like people ask me, oh, do I need to show the intermediate step when I take negation? Sure, you don't have to show it, but showing it will help you if you make mistakes. Okay? Because if you make mistakes, they can look at your intermediate works and give you partial marks. Otherwise, how do I give you a mark? You know, if you only have the final answer, how do I give you a mark? Okay, so the following are important. So the negation of P and Q. The first two are called De Morgan's law, by the way. So those two are called De Morgan's law. I don't know if I'm spelling it wrong. De Morgan's law for logic. Okay, so you can use them now. So De Morgan's law, negation of P and Q will become negation of P or negation of Q. So and becomes or. Okay, and becomes or. Similarly, negation of or will give you and. If we use it, I think you should, but I don't think we care about it that much. But to be safe, you should cite it, because De Morgan's law is quite famous, isn't it? It has a name, you know. When something has a name, you know, it's important to know and important to cite it. Okay? De Morgan's law. So that's the first two. And the third one is where people make mistake the most. The negation of P implies Q is P and not Q. This you have to know. Okay, I cannot emphasize how important it is, because this is where people make mistake all the time, every semester. Okay, after you take negation, there should not, you don't have implication anymore. So the most common mistake is like negation. So a lot of people do this. They think this is negation P implies negation Q. That's absolutely incorrect. Okay, negation of P implies Q is P and not Q. This, please don't make the mistake. Like, it's really sad to see people make the same mistake over and over again, even though we emphasized it over and over again. So keep it in mind, okay? Keep in mind. The next one, P if Q is equivalent to P implies Q and Q implies P, we talked about it already, right? So this is, you should know already. And the next common mistake is this. Number E, okay, this one is called the contrapositive of the statement. It's another common mistake. So this 3 stars. I'm gonna give it 5 stars, not even 3, because this is even more important than C. This is called the contrapositive of the statement. Why do I emphasize it so much? Because you guys probably know, for proof technique, we have direct proof, we have contrapositive, we have contradiction, right? If they ask you to prove by contrapositive, and the contrapositive you wrote down is incorrect, you will just get 0 immediately. Okay, because how do we even give you partial marks when the thing you're trying to prove is not even correct? Okay, so this is extra important. So the most common mistake is like this. I'll even write it down. So the common mistake is they do it like this. They think P implies Q. The contrapositive is negation P implies negation Q. This is, and let's put a big no here. Okay, this is incorrect. But every year, every semester, we see a lot of this, and people get 0 because of it. Just imagine this: you have 5 questions in a meter. Okay, one of them being multiple choice, which means it's not even gonna worth a lot. So the proof questions, for example, a proof by contrapositive question would worth a lot. And you made a tiny mistake. It's not even a huge mistake. It's just you roll the contrapositive incorrectly, and you even tried a lot during your test, but all the effort you put in worth nothing just because of this mistake. So it's really not worth it, and I really hope you can get it. Can we use shorthand? No, don't do that, because your TA would not understand your shorthand name. It's not a common abbreviation. DM it's not a common abbreviation, unless it's something everyone uses. Otherwise, don't do it. Okay. Yeah. Otherwise, your marker will be like, "What are you talking about?" Right. So be clear is better. All right. And the next, the negation of quantifiers. Again. This is common mistake as well. Okay. Oh, we see this all the time. So if you take negation of for all px, you change the for or to there exist, and the negation px. Okay, for or to there exist, there exist to for all. They are negation of each other. So what is a common mistake people always path is, so let's write it here again. So common mistake is, for example, I have for all x in real number, x squared are equal to 0. Okay, so now I want to negate it. So negation. The correct one is you change for all to there exist. Okay, and you negate this. So the negation of this will be switch the inequality. So if it's greater than or equal to, you change it to less than. Okay, so this is the correct negation, but the incorrect one is, a lot of people will think, well, for all x in real number, the opposite of that is for all x not in real number. And then we'll do this. This is incorrect. Okay. This is also incorrect. A lot of people do that. Every semester, this and this. Too many people do this that I emphasize it every semester. Will there be hidden quantifiers in the questions? What do you mean hidden? Will be really clear for quantifiers. Okay. Oh, they give you a sentence. If they give you a sentence, yes. But if they write it in logic symbols, you already know. Okay? In sentence, yes. It's very possible. In logic symbol, no. The mistake is here. Okay, this is a mistake. When they try to negate the quantifier, they got it incorrect. Okay? So you have for all, you change it to there exists. Whatever is for all in what, you leave it. Okay? Make sense? Let me check. Cool. Alright, so I really hope you don't make those kind of mistakes. So before your test, okay, I'm really serious, because making those mistakes, you're not gonna do well in this course. Those tiny mistakes can cost a lot. So before your test, like before, let's say 2 hours before a test, you don't want to do more questions anymore, right? Because you want to save some energy for your brain for the test. So what do you look? You should go back and look at those common mistakes. Okay, go to the most basic stuff. Go to the concept checks. Ask yourself, well, do I remember all the concept correctly? Instead of doing more questions, you should recall the concept. You should think about, what is a negation? Do I have it correctly? Okay, because those are the ones that's really easy to make mistake. It's not the hard part that people don't get it. Sometimes, a lot of time, it's the easy part, people don't get it. So before your meter or your quiz, you should always go back to the most basic stuff. Make sure you have them correctly 100%. All right, so now let's try 4. So they asked you to find a truth table and determine if they are logically equivalent. So those 2 statements. I'll give you a little bit of time to try it yourself. You should be extremely comfortable with truth tables, okay? Extremely comfortable with truth tables. And for your TA, for whoever's grading, I'm doing them a favor, please. Because if you don't do this, it's gonna make their time really hard. Okay, so please, if you draw your truth table, always start with P and Q. Okay, and then whatever you have next, that's on you. Be based on I don't know, because she hasn't posted homework 3 yet, so I don't even know what's homework 3. I have no idea. Okay, so you should always start with P and Q, and with the same order of true, false. So for P, always do true, true, false, false. And for Q, always do true, false, true, false. Okay? This will make the marker's life much easier if there is a truth table question. Otherwise, it's gonna be a pain to grade it because we need to check the whole thing. Usually just check the very last column, but okay. So try this and put the other ones there too. But the first 2 columns, please make sure they are the same, so that it's easier for the marker. You don't really want to make their life hard because otherwise it's gonna take them forever to grade, and you'll never have the back because it's gonna take them too long to grade. So the easier for them to grade, the better. You'll get it back soon if you do that. So let's put those all together. So you can see I have this, I have this, I have this, I have this, and then just those the 2 biggest one. And implies P. Okay. So give it a try. Oh, water. Well, the topics, I don't really know. I don't really know, I suppose, but I have no idea. That's a question from Marina, to be honest. She hasn't even told me what's gonna be on her test yet. Like, I don't even know. Yeah, I don't even know what's gonna be on her test. Maybe she'll do it when she make your homework, I think. I think the instructors would know, but I don't really know. If there is a logic question. From past experience, the one in logic chapter could be a proof question using either contradiction or contrapositive. Could be like a truth table question, like what we're doing now. Okay, could be write the negation of a statement, determine if it's true or false, and give the reasons. Like all the ones I've said, they've showed up before and very frequently. Let me think. I think that's about it. Yeah. I don't know, I suppose the past tense supposed to be similar to that, but I'm not very sure. Yeah, again, I don't even know what's on your, I don't even know what topics will be covered on your test, so I really don't know. It's hard to say. Like, I'll make some comments when I know what topics will be covered. Okay. Yes, only P implies Q has contrapositive. Only this. So only this has contrapositive. Alright, so let me take it up. So quickly take it up. If we need to check that's correct, you need to check both directions. Okay, so if P is true, true, false, false, negation P is the opposite of it, so that's gonna be false, false, true, true. And negation Q is the opposite of Q, so that's gonna be false, true, false, true. Okay? So those two should be really simple for everyone. Okay? And now let's do this implies this. So this column, because this column implies this column. Remember for implication, it's only false when you have true implies false. So let's say there's a true implies true, true implies. So this is the only false case. Only when you have true implies false, you will have false. Everything else will be true. So let's put true for everything else. Okay. And then for if and only if, I said it's only true when those have the same truth value. So you compare this with this. When they have same truth value, you put true. When they don't have the same truth value, you put false. So true, false, false, true. Okay, so you see those two, they have same truth value, same truth value. And next, this one. So you're checking this column with this column, check if they have the same truth value. So this is false, false, true, false. Okay, because this is the only time they have the same truth value. Alright, and then lastly, you have an implication. So implication, I said, well, it's only false when you have true implies false. So we are checking this. Implies the first column. True implies false, true implies false. So the last one. So the last one, remember? So this is false, and everything else will be true. Okay? Any question for the truth table? Question for truth table? We're all good. For the now, vacuously true? You meant? Not P. Now Q implies P. Now Q implies this or this? First one or the second one? First one to the left. This one? I did. I said I said it's only false when you have true implies false. So true implies false. This is the only case it's false. The vacuously true one will be false implies something. Right? Those are all true, so I don't need to care about them. Because the only case it's false is when you have true implies false. Okay, the vacuously true, they are true, right? Okay, another method to draw the truth table. You mean 0, 1? Are you talking about 0, 1? The Boolean algebra one? Or which method are you talking about? Philosopher 245, how exactly did they draw it? I mean, I never took that course, so I'm not sure what you're talking about. No, don't use 01. Do not use 01. This is a math course, so try not to bring CS here. Because your TAs are math TAs, okay? Let me see. Oh, I don't recommend that. Because the reason is because you are not allowed to use something outside of you're not allowed to use something outside of the course. So however this course taught you, you do it in this course way. Most of them end up in CS. That's not true. Most 102 TAs are not in CS. I'm not in CS, for example. Daria is in math school, not in CS. Rain is doing math specialist, not CS. Most of us are not in CS at all. Who aimed for CS? That's CS TAs for sure, but 102 TAs, not really. 102 TAs are from all different kinds. Like we've had a TA. I mean, that's this semester, but last 2 years ago, one of the TA was just finished law school. And they were TAing 102 when they were in undergrad, and they went to law school. They finished law school and they're like, oh, I missed TAing 102. So while they were doing their lawyer stuff, they also did a TA part-time as 102 TA. So 102 TA and CS, they're not that related. Yes, we get paid. Yeah, like Dara is currently in med school. What other TAs do we have? A lot of us are not relating CS at all. Not at all. Anyone be receiving? Those are scam. um, ignore all those job offers. Those are all scam. Okay, you report them. There is a report option, and you click that. Don't trust those. Those are all scam. Let me see. Who else do we have? Like Daria, not in CS. Daniel's doing grad school in math, I think. Also 9CS. Andrew 9CS math as well. Harshit is in CS. So far I've seen one CS. Is that Rain, Nicole? Yeah, Akira is in CS as well. Yeah, one, I mean, maybe a few, but most of us are not in CS. We're not related to CS at all. Paris, Akira's in both. Akira's in both. He is TA in CS courses as well. So like double major. I don't even know if he's doing double major. Maybe a specialist major. You can ask him if you're interested. Okay. Harris, I have no idea. I haven't spoken to him about. I mean, we've met, but I don't really know. Okay. If you're interested in any of the TA, you can DM me. I'll try to ask for you. I mean, interested not in the relationship interest, okay? That I cannot help you. But if you're interested in what they're doing, you want to talk to them, I can ask for you. Yeah. Relationships, nah, it's not, it's not allowed, okay? We're not allowed to date students. I'm saying this like, do you need a high 90 in 102? I don't know. I have high 90. Daria has 100. For other TAs, I never asked them. So, I never asked their mark, so I don't really know. I can only tell you the ones I know, so, you know, I know my grade. I know Daria's grade. Daria got 100 in most of the course. In a lot of courses. Not most, in a lot of courses. I did high school in Canada. I did high school in Ontario. In Toronto. My high school, I don't know if you guys know, it's somewhere near Ellesmere and Victoria Park. Anyway, continue, guys. Let's do 102. If you wanna talk about something else, we can stay after we finish this, and I can answer more questions about something else. Okay. But now let's do 102. So a question like this, all you have to do is construct not all, but you're mostly down. Okay, so the next part, you need to answer the question. Are they logically equivalent or not? No, okay, everyone said no, but why? Why are they not logically equivalent? So this part, the why part, you need to put it down on your paper, okay? It's part of your solution. You should explain why. They do not have the same truth value, exactly, okay? So this, you should write down. So what I would do is I would highlight the last two columns. So highlight those, and I say no, okay, no. They are not logical equivalent. They are not logically equivalent. And then you can explain why. You can say, oh, since they have the different truth value. They have different truth value. Okay, you can even say the last two columns. Okay, so this sentence is important. Don't just leave a truth table and call it the end of the day, because you're not really answering the question yet. Okay, make sure you always answer the questions they ask you. Are they logically equivalent? You should answer, right? You should answer and tell them why. So you did most of the work when you draw this, but it's not complete. Okay, so make sure you complete. The next, which of the following statement is equivalent to this? So, well, obviously you need to draw a truth table again. Draw this. I'll leave this to you because it's a good practice for you to see if you understand what's going on. So this, I'm gonna say do it yourself. I'll post solution later, but do it yourself as a check your understanding. Okay. Unlike Venn diagrams in proof, truth table is a form of proof. Venn diagram is giving an example of what your set could look like, but truth table it basically lists out all the possibilities. That's the main difference. Venn diagram does not cover all the possibilities, but truth table covers all the possibilities. Okay, so it covers all the combinations of the statement being true or false. All right. Another thing I want to mention, because it's not here, but I'm worried that it's gonna show up. Okay, so another thing I want to emphasize is if, all right, let me write here. If your compound statement, which means the statement that's being connected by several statements, simple statements. If your compound statement has, let's say, 3 simple statements, like P, Q, and R. P, Q, and R, then your truth table should have 8 rows. Okay, so 4 rows like this is not enough to cover all the cases anymore. It's 2 to the power of 3. This is 2 to the power of 3. Okay, so if you have 3, you need 2 to the power of 3 different rows. If you have 4, then you need 2 to the power of 4 rows. Okay, understand? So you have true, 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 false, 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 false. True, true, false, false, true, true, false, false. True, false, true, false, true, false, true, false. Like that, okay? And true, false. So this is the reason, okay? This is the reason when you don't have to construct truth table, we don't recommend you do that. Because for something like this, I can make it make it be combination of many simple statements. And if you only use truth table to show me, then it's gonna take you forever. Do you guys understand me? That is why unless you have to use truth table, like show logical equivalent, otherwise if there is a different way, you try a different way, especially if you have more than 2 simple statements. Does that make sense? I feel like my iPad is lagging. Can you guys see me move at all? No? Yeah, that's what I think too. Okay, let me close it. Let me reopen it. I don't know what's going on. Yeah, I feel like it's not working for some reason. Just give me a moment. I think it's Zoom problem. It's Zoom problem for me. Is it working now? Can you guys see it? I moved it a bit. Okay, good. So as I said, okay, if you have, let's say PQR, let's say another one as, for example, then to construct a truth table, you need too many rows and takes too much time, right? So in that case, unless the question is asking you to show logical equivalent, otherwise, like those questions, remember, you don't have to do a complete truth table. You can deduct your answer based on what we know about the statement, right? Do you guys remember from the in-person tutorial, those questions? You guys remember that or no? You're fine? Yeah? So what? You don't remember? Yeah, let's review a little bit. Let's do this one. I'll review this one. You should be able to do the other ones, okay? So this is what I'm saying. In this case, you only have PQ, so even construct a truth table is not gonna be too bad. However, if I give you PQR as, for example, all combined together, then the truth table is gonna be pain, right? It's gonna be a pain. So instead of doing that, you can deduct your answer directly from this. So for example, we know this whole thing is true, and we have an and statement, remember? Something and something is true. We know that for and, it's only true if everything is true, right? Yeah, so because of that, we know this is true. We know this is also true. Because for and statement, it's true, only both are true, right? So we know this. And now, because P is true, this must be false, okay? And Q implies false is true only when Q is false. Why? Because if it's true, then you have true implies false. True implies false is the only false case, remember? But you want it to be true, so you want it to be vacuously true. Okay, so in that case, you know P must be true and Q must be false, instead of construct a truth table. Does that make sense? Last 4 questions, example 4. Yes, you do need to explain. Unless they say no, otherwise you have to. So let me go back to questions. So they want us to check logical equivalent for PQR because it takes, I'm not saying it's impossible. I'm saying, because they've done it before, Dana, I'm sorry, because this happened before, so I don't want to say it's impossible, because they did that before, okay? They kind of forced you to construct a truth table which has 8 rows. It happened before on a quiz, I think. So it's not impossible, but what I'm saying is, if you can avoid it, then you try to avoid it. If it's not possible to avoid it, then of course you have to do it. Okay? Yes. If you don't have to do it, then why would you waste your time, right? You should spend the time on the harder questions. That's my point. Okay? Yes, exactly. Rather than list out all possibilities, if you can deduct the answer, then you go ahead. And save the time for something else. Okay? Any other question before I move on? So, as I said, if they ask you to show logical equivalent, and they are in fact logical equivalent, there is no other way. You have to draw the whole table. If you want to say they are not logical equivalent, okay, so for example, you want to say 2 statements they are not logical equivalent, you don't even have to draw a whole truth table. You can, let's say, you figure out in certain cases they don't have truth value, you can say it directly. But sometimes you might not figure it out without a truth table, so it's kind of like that. I'll show you when I give you solutions, I'll show you what I mean. But if Q implies negation, P is true. Q implies negation P. We're talking about this as true, then Q can also be no. If this is true, if this is true, then you will end up with true implies false, and this will give you false instead.
But it says it's negation of P, so wouldn't that make it true then in the end?
Negation of P is false. Okay, because P is true. Remember? P is true, so negation of P must be false.
Oh, okay.
So we have Q implies false. If this is true, then the whole thing is false.
Okay, that makes sense.
Okay, any other question? Okay, so as I said, if you want to show logical equivalent, you have to construct a truth table. If that's not the case, then maybe it's possible you can avoid it. And if you know how to avoid it, then sure, go ahead. But let's say during your test, you forgot how to do it. For example, like this question, you forgot how to do it. You forgot how to deduct the answer without a truth table, then go ahead and draw a truth table. Okay, don't think like, oh, Lin said don't draw a truth table, so I'm not gonna draw a truth table, I'm gonna give up. No, okay. If you don't know how to do it without a truth table, then go ahead and draw a truth table. It's not wrong, it's just might take you more time. I tell you that so you learn it, okay? If I don't tell you that, you're not gonna try hard and you're not gonna treat it seriously. I'm not actually gonna laugh at you. But you should keep in mind that I will laugh at you, so you try hard. But I'm not actually gonna laugh at you. Come on. That's mean. We can explain. Exactly. Explain like this, explain is enough. So we don't have to. Okay? Now let's do 5. We're spending a lot of time on that. So let's do 5. Consider the statement P, which is y greater than 2. R is x greater than x plus y. The both numbers xy. Which of the following are true? Okay, prove it or provide counterexample for the first one. So I'll give you some time to think about all 4, and maybe you can let me know which one do you think are true. Okay. You know why I tell you I'm gonna laugh at you? When I was in grade 8. Yeah, I even remember. Grade 8, when I was in grade 8, I was in China, and my middle school has a math test every Sunday night. So every Sunday night, we need to go back to school and write this math test every Sunday night. And it was out of 150. So the math test, it's out of 150. Okay, the first 10 questions are multiple choice questions. So, and then you have a bunch of long answer questions. And back in grade 8, I was one of the best in my class. Not just in my class, I was one of the best in my whole school for math course. So for me, I pretty much never got below 140. It's out of 150. I pretty much never got below 140. But one day, it was one of the tests. Really sad. I made a mistake, and the mistake was it was part of the question. Okay, part of one question. There is one calculation. It's really simple. I still remember it. It was 62 plus 4. Okay, it's part of the question. I need to calculate it. It's 62 plus 4. I wrote this equals to 68. It's a stupid mistake. Okay, this stupid mistake cost me 2 marks. So because of this, they did -2. Yeah, no calculator is allowed. But I mean, this you don't even need a calculator. I lost 2 marks on this. So instead of 150, I got 148. Okay, I got 148 because of this tiny mistake. And that whole test, nobody got 150. Not a single person. In my grades, we have 1,000 people. Okay, in those 1,000 people, not a single person got 150. And I was the highest grade. 140 was the highest grade in those 1,000 people. And the reason I did not get perfect is this mistake. So my math teacher was really, I wouldn't say he was mad at me, but he was really speechless, you know. It was really speechless. He was like, during our math class, he asked me to stand up, and he asked me, he's like, what's 62 plus 4? I was like, 66. And he's like, no, why did you write 68 on your test? And I was like, I did. You know, I was like, I did. And he's like, well, you'll see when you get your test back. So I got my test back, and that's my only mistake. And that's the only reason I did not get perfect on the test. And that's the only reason nobody got perfect in 1,000 people. No, that's not a single person got perfect. And he made fun of me during my whole class. Like he asked me to stand up, asked me, and later I was in his office. I didn't even go to his office for him. I went to the office for a different teacher, for my Chinese teacher. I asked her something, and he saw me. He told everyone in the office. It was a huge office with all the teachers in our grades. So like my Chinese teacher, all the other people's Chinese teacher, all the other people's math teacher, every single person, all those teachers are there. And he's like, look at Lee. Lee did 62 plus 4 is 68. And then I was like, yeah, sorry. And I laughed. Later, when I went to the print shop to print something, and on my way to print shop, I met him again on the stairs. So I was going down, he was going up. He saw me again, and he was with some students from a different class. Okay, from a different class. And he saw me again, and he said the same thing in front of everyone again. Like till that moment, basically every single person in the whole 1,000 people know I made the mistake. Everyone knows that I didn't get perfect. The reason nobody got perfect in this test is because I made this stupid mistake. Okay, so after this, he doesn't hate me. Okay, he doesn't hate me. He's a great math teacher. I can do well in math only because of him. He's a great teacher, and I'm thankful. To be honest, I'm really thankful that he did that. It's mean, I agree. It's really mean that some people might not even be able to take it. He knows that I can take it. That's why he did it. But because of that, I pretty much double check, triple check my calculation in all my tests. So after that, those mistakes just never happen again. From since grade 8, I haven't made a single calculation error because I triple check. Like I check once, check twice, check 3 times. I was like, okay, that's correct. Even when I teach calculus, you'll see that my students see me after I finish it. I always go back and check if I made any mistake. It's just like I always do it. You know, tackling. I'm just telling you, like with that in head, with that, it's been so many years. I still remember this mistake, and because of that, it just never ever happened again. Because I always remember that I made this mistake, and I should never make this mistake, and it really helped me because if that didn't happen, I don't think I would triple check my answer. It's just not gonna happen. You know. So well, obviously I'm not gonna laugh at you because I think it's mean, and I've experienced that. I'm not gonna do it to you, but I want you to have that in your head. Think someone will laugh at you. Because of that, then you'll double check your answer, you'll triple check your answer to make sure it's correct. Okay, it will actually help you. I feel like without him I wouldn't be here, to be honest. It's something you should keep in mind, that we don't make those stupid mistakes. We don't make those minor mistakes that might cost us a lot. Okay, so truth table questions, you should not let it be one of the reason you got marked deducted. Because as I mentioned, each 1 mark is 1% of your whole grade. Proof similar triangles. Anyway, so which one of the following do you guys think is true? True, false, question mark? Oh, never mind. True, false, You got 2 correctly. You think all of them are true? That's not correct. Oh no, what are you gonna do if this is on your test? Only one is true? No. True, false, vacuously true. That's correct. So nice. Good job, Adam. That's correct. True, false, vacuously true. Okay, let's talk about it. Let's talk about it. The first one is true. I'm not gonna write the full answer, but we'll go over it. Of course, we'll go over it. Okay. So, why is it true? This is saying that for all y in real number, for all x in real number. So basically, they are telling you x and y are real numbers. Okay, so this is just telling you all x and y are real numbers. It can be any real numbers, and this is saying that if x is bigger than x plus y. Okay, if thus, what can we get, by the way? What can we get? X is greater than x plus y. So what does it mean? It means y is negative, that's correct. So this tells us y is less than 0. That is correct. Now, they're asking you, well, if y is less than 0, then we have this. Is this true or not true? So now your goal is, well, I'm trying to get this to this. So you can observe those two statements and see what's the difference. So I see that, well, instead of y, I have negative y here, right? I have negative y here, I have minus y. So I'm gonna multiply both sides by negative 1. So I can get negative y is greater than 0. Okay? And then add 2 on both sides, you have 2 minus y greater than 2. Right, and you divide 2 on both sides, you have 2 minus y over 2 is greater than 1. And thus, it's basically thus, because this includes the case thus. Thus is basically saying, remember I said this is greater than or equal to? Greater than or equal to? You can pick one of them to be true because it's or, remember? So as long as one of them is true, it's true. We show that this one is true, so it's true. Make sense? Why is... Well, I thought you... Okay. X greater than x plus y. Okay, remove x on both sides. Then you have 0 is greater than y. Okay, make sense? 0 is greater than y, and y is less than 0. They are the same thing. Make sense? So we start by assuming R is true. That's correct. So as I mentioned, I think I mentioned it from before. So when we talk about vacuous picture, remember? Here, when we talk about vacuous picture, I said if your P is false, then it's vacuously true. But if your P could possibly be true, then you assume it's true. So unless it's impossible to be true, you assume it's true. If it's impossible to be true, then you say it's false. Make sense? So yeah. So for example, let me give you an example. So for example, for all x in real number, x is greater than 0 implies x squared is, for example, greater than 1. Okay, it's a false statement, but why? So think about this. For all x in real number, x is greater than 0. You might say, well, not all x are greater than 0. But it's possible the x you pick are greater than 0, right? Do you agree? So this it's possible true. If it's possible true, it's possible we have this, then you assume this is true and show this implies this. However, if I have this, if I have x squared is less than 0 implies x equal to 1, for example. Okay? In this case, this part, x squared is less than 0 under the assumption that x is a real number, it's impossible to be true. It's always false. In no cases this can be true. Make sense? So then it's a vacuously true statement. Make sense? So if possibly this can be true, then you assume this is true. Otherwise, if it's impossible to be true, then it's a vacuously true statement. The other case is this. So let's change this statement to a different one. So if I have for all x in real number, x is greater than 0, implies for all x in real number, x squared is greater than 1, for example. Okay, then in this case, you will see that, well, this itself is a statement. Unlike here, this quantifier works on the whole thing here. This quantifier works on the whole thing here. So this is not a statement yet. It's part of a statement, but here, this is a statement. This is so telling you, well, all real numbers are greater than 0, which is false. Do you guys agree? In this case, this is false. Okay? Okay, so this is telling you all x in real number is greater than 0, which is false. But here, this is saying, well, for all x in real number, if x is greater than 0, then x squared is greater than 0 or greater than 1. Okay, so that's the main difference. So in this case, this will be a vacuously true statement. I mean, this one is a vacuously true statement. This is a vacuously true statement. This is a false statement. Okay, make sense? It's really important to distinguish those. Okay. So in this case, back to here, do you guys understand why the first one is true? This is true. Okay, makes sense? All right, so let's look at the second one. The second one we said it's false, so let me write down it's false, but we'll talk about why it's false. The second one says, for all y in natural number, okay, we have x in natural such that y greater than 2 implies x is greater than x plus y. So again, this is equivalent to y is less than 0, right? So they are saying for all y that's greater than 2, we have x is greater than x plus y. We always have x in natural number such that this is true. So you can just pick any y because for all y in natural number, right? So you can just pick any y and give a counterexample. So for example, counterexample, you can say, well, when y is 3, for example, which is greater than 2, okay, we have x plus y, which is x plus 3, right? X plus y is x plus 3. This is always greater than x. So it's impossible to be smaller than x, so this is false. Does this make sense? Make sense? Yeah. Okay, let's look at 3. For all y in real number, for all x in real number, if y is greater than 2, then x is greater than x plus y. This is also false, and you can use the exact same counterexample. You can use this counterexample. They are not the same statement, but the counterexample works for both. Do you guys see? Because it doesn't matter your x is natural or real or not. There is no such thing. Okay? Makes sense? Same counterexample works for both. All right, so let's look at the last one. The last one says, for all y in natural, there exists x in natural such that y is greater than 2. Well, P doesn't even have x, so you can ignore this part, okay? Because it doesn't even have x. So let's go back to this. It says, for all y in natural, y is greater than 2. Is it true or false? For all y in natural, y is greater than 2. This is obviously false, right? This is false because you can have 1, you can have 2, right? So not all natural numbers are greater than 2. So this whole thing is a false statement, which make the whole thing vacuously true. Okay? Victoriously true. Vacuously true, yeah. Victoriously true. I feel like I've seen this on meter. People write it wrong. Vacuously true, they write it in some other thing. And the teacher asked me, shall I deduct mark? They're like, do we deduct mark? They wrote it wrong. I was like, let's just be nice. I was like, I'm sure they know what they're talking about. They just can't spell it. Anyway, do we have any question about this example? Oh, we good enough? Yes. So you should explain several things. So you should say, well, why this is false. Okay. In this case, you can say, well, y is 1 it's a natural number, but 1 is not, is less than 2, for example. So you can say, oh, this whole thing is false. And because it's false, we have vacuously true statement. Okay. I'll give you a formal answer. It can be true if it's a statement, can be false. So again, you're asking the same thing. So here, use those 3 examples you should understand. So if like this, okay, if like this, the quantifier works for the whole thing, then you assume it's true if it can possibly be true. Okay, so for example, in this case, it can be true. The x you pick might be greater than 0. If it's possible to be true, then you assume it's true. However, even when this works on the whole thing, in this case, it's impossible to be true, so it's a vacuously true statement. Make sense? Yes, that's correct. That's exactly. Yeah, and in this case, well, this statement is obviously false, right? So, okay. Exactly. All right, so let's do number 6. So which of the following statements are true? Yeah, we do need to show. That's what I said, right? You can consider y equals to 1, which is in natural, and it's 1 is less than 2, so it's false. All right. So one of you said it's true, vacuously true. No, if it's vacuously true, we don't really care about the other part anymore. Okay. vacuously true, you don't care about this. Either it's true or false, it's always true. What about other people? Do you guys agree? You guys agree that true, vacuously true? Still thinking? Yeah? That's correct. That's correct. That's great. That's great. That's great. That's great. This is true, 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 true. And then those two are vacuously true. Anyone name me two? Do you have to differentiate? You don't have to, but it's better to say it. The reason is for vacuously true stemma, you need to tell us it because it's vacuously true. That's why you don't need to check the later ones. Okay. If you don't tell us, then we would require you to check everything, right? Why are the first two are true? Okay, then let's read. Every natural number which is greater than -5 is greater than 0. Is it this? You can say so the first one you can say the statement is true. Okay, let x be a natural number, then x is already greater than -1 and it's already greater than 0, so you're done. Okay, because we know natural numbers are greater than -5 and greater than 0, right? So you're done. Okay. Two, you can write something similar. You can say, well, let x be a natural number and x is greater than -5, right? Then x is greater than 0. Why? Because since natural numbers are greater than 0. So a short explanation is enough. Or positive, for example. Okay? Make sense? Okay, so next, if a natural number is less than -5, then it's greater than 0. So you can say, well, this is vacuously true. Why? Because, well, the first part, greater less than -5 is false. Since you can say since all naturals are positive, you can quote this, a natural number is less than -5 is false, is always false, which means the whole statement is vacuously true. Okay, so I'm not gonna write that, which means the whole statement is vacuously true. Okay, and 4 is exactly like 3. So I don't want to write it. Does this make sense? So using those examples, you should have a solid understanding on what's vacuously true. Okay, make sense? This is good. Okay, so now let's go over the concept check, shall we? Let's go over the concept checks, because I should not show you this. It's a TA chat. Here, concept checks. So hopefully you already did all of those. So let me review the answer now. Anyone hasn't done this so far? Do you need the time to think about it? You all did that already? 2 minutes? You want 2 minutes to do it? Okay, I'll give you 2 minutes. I'll go to washroom. When I come back, we can start. Okay? For 9, do I have to say P and Q must have the same truth values? Or can I say... No, they don't have to be true. So can I say P implies Q and Q implies P must be true? They don't have to both be true because they can both be false as well, right? When they are both false, the whole thing is also true. So that's not correct. Dual seat setup. Oh, it's not the seat. That's not my desk. my setup is only one desk. So this is our home office. For 12, I'm asking your quiz 1, question 1. So quiz 1, question 1 says it says let A be a real number. Show that if A is not 3, then the equation x squared plus blah 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 equal to 0 has exactly 2 real solutions. It's self-reflection. It's not, yeah, it's self-reflection. It's check your understanding, okay? Only checking your understanding so you know what's going on before you do questions. Okay, so let's go over this. You can send your answer in the chat, of course. So what is a mathematical statement? Send it in the chat. You should know all of those, okay? As I said, you should not guess. You actually know the answer. You need to be 100% confident. A statement with only a true or false value. Pretty much, yeah. So it's a statement, or not statement, it's like a sentence or a claim that can either be true or false. Okay, it cannot be sometimes true, sometimes false. Cannot be both. Okay, cannot be neither. It has to be either true or false. Exactly. Okay, so seems like you guys know what's going on. So there are 2 types of quantifiers. Where are they? We talked about quantifiers. What are the 2 quantifiers? For all there exists, that's correct. Okay, so 3, true or false. To show a statement is false, it is enough to provide a counterexample. Uh-oh. Uh-oh. To show a statement is false, it is enough to provide a counterexample. This is false, okay? This is false. 3 is false. Exactly, depends what kind of statement you have. Remember, if it's universal quantifier, if it's universal statement, then that's correct. But if you have extensional quantifiers, then this is not correct. Remember in tutorial, we talked about this? Do you guys remember in tutorial we talked about this? It depends on what kind of statement you have, depends on the quantifier. Okay, 3 is false. This is why we need to do this, you see? Number 4, the order of quantifiers does not matter. Switching orders would not affect the statement. True or false? Okay, that's great, it's false. Okay, so 3, those of you who answered wrong, you need to go back and review, okay? It's only true when the quantifiers are the same. So if they're both universal or both extensional, then it's okay. But if there are different quantifiers, you cannot switch order, which we talked about it as well. Okay, so don't switch order of the quantifier. That's gonna change the whole statement. For 3, if the quantifier is for all, then it's a true statement. So to show a universal statement is false, it is enough to provide a counterexample. That's correct. It's in tutorial 4, Discord. Yeah. Concept check. Okay. Number 5, can you summarize the truth table for P and Q in one sentence? Okay, only true when both are true. That's correct. Okay, nice. Can you summarize the truth table for P or Q in one sentence? Nice. Okay. Looking at the concept check, I'm more confident for the midterm now. We need to do concept. Shall we do concept check for the first few chapters? Do you guys think it's a good idea? Okay, so I'll write that later. Let me find the time. Okay, number 7. Can you summarize the truth table for negation P in one sentence? The opposite, that's correct, the opposite. Okay, can you summarize the truth table for P implies Q in one sentence? Okay, that's correct. Only false when you have true implies false. Okay, only false when you have true implies false. Can you summarize the truth table for P if and only if Q in one sentence? That's correct, that's correct. It's only true when they have the same truth value. That's great. Okay, number 10. Can you explain why rough work is not a proof? I talked about this in the in-person tutorial as well, right? Remember? You guys are right, but you're not explaining it. You just say we cannot start with a conclusion, but why can't we start with a conclusion? Exactly, Hansel, that's great, okay? It's because P implies Q and Q implies P do not necessarily have the same truth value, right? Remember I talked about this? I said P implies Q, Q implies P do not necessarily have the same truth value. So if I ask you to prove P implies Q, but you give me Q implies P, you're not proving the statement. Remember, not all steps are reversible, that's correct. Not all proofs are reversible. Exactly, okay, this is great. Okay, I'm really happy to see this. Okay. 11, to prove P if and only if Q, what do I need to prove? We need to show, that's correct. Okay, we need to show P implies Q and Q implies P. Exactly, to show both direction work, exactly. Okay, nice. Okay, number 12. When the question asks to prove P if P then Q, so we're talking about your quiz 1, question 1. Your quiz 1, question 1, let me show you in a moment. We talked about here. This is your quiz 1, question 1. Okay, I'm asking to prove this, and my argument here is, since A can be any real numbers, A does not equal to 3 is false. The statement is vacuously true. Can we do that, or why or why not? Okay. That's correct. Okay, that's great. That's great. I'm really happy to see this. I'm very happy about the result of the concept checks. That's correct, because well, A does not equal to 3 can be possibly true. Okay, so we assume this is true and prove Q. That's exactly what we were discussing earlier. Exactly. Okay, so I hope this concept check really reflect your your understanding. Okay, because and remember 3, okay, a lot of you got 3 wrong, so you should go back review the quantifiers, the 2 types of quantifiers. Okay, you don't need to be sad, because if I were you, I would be really happy, because from here, instead of doing your test, okay, before your test, you figured out you don't understand this, right? So it's good that you know your mistake or what you're weak at before the test. Otherwise, if you know it, you realize it during, you make the mistake during your test, that's bad. But if you make the mistake before the test, that's a good thing. Okay, so we should do more concept check. This is for part 1. This concept check is for the in-person tutorial. So after the online tutorial, which is now, we will do another concept check. So I'll make another one and post it the same place. And we'll do concept check for the other concepts too. No, it is a statement, because to show a statement, so this statement can be any statement. Okay, so generally speaking, it's false. It's like the for all ones. It needs to be always true to be true, right? Study tips. Well, actually, I already told you my study tips during the tutorial. Remember, I told you the reflection. I told you you need to go back to the concept. That's how we study. Okay, that's how we do well. You need to make sure you actually know what's going on before you do more questions. Textbook questions later. Again, the practice question, I wanna post it after I know what's gonna be covered for a test. Because right now I don't even know what topics will be tested, right? So because I don't even know what topics will be tested, it's really hard to give you any recommendations. So I wanna know when at least she tells me, you know, at least I want to know what's going to be tested before that. So at least she tells us, well, for example, the whole chapter 3 will be tested, something like that. Okay. All right, so I'm gonna stop recording here. If you have any other question, you can ask. I'll stay here for a bit. If not, you may leave anytime you want. Cool. Let's stop recording now.